So my name is Utku. My background is I have computer science master's degree from Northwestern, and I have data analytics information systems PhD from University of Illinois Urbana-Champaign. I first started as clinical professor at Urbana-Champaign, then I moved to Chicago. I was the lead data scientist of Granger. I worked in Goldman Sachs before and some couple of financial services companies. And recently, for 2 years, I'm leading the data science team of a healthcare analytics company, which I'm heavily spending all of my time nowadays to healthcare analytics problems. And I'm going to talk about a little bit effort that we are trying to do in our program as well. So I always start the big picture, where we are and how we can actually plan ourselves and be ready for the future to be able to adapt new skills for ourselves. So in early 1990s, there is an era which I call readable, when the first big data and analytics actually became available, that the information was broadcasted from one source to the many. In the second era, in 1990s, people started to create dialogues, and the communication medium became many to many. People got connected. Previously, we were just ingesting the information dump that's transmitted or broadcasted to us. And then after that revolution that created social networks, interaction, user-generated content, also the data types, data structures changed. Like we had to deal with the text, image, video, audio, not only structured data that we were able to do a lot of statistical analysis by using spreadsheets, but now we have to deal with a lot of different components of this new stream. And it actually allowed a lot of different analytical capabilities where we are at right now, including data mining, artificial intelligence, machine learning, that we are analyzing behaviors, preferences, we are using worldwide database data, different structures, and predicting people's or other systems intentions, which we call executable. So the first era was like readable, second era was writable, and now we are in an executable stage. Why it's important, if you're familiar with, everyone is talking about big data, it's actually big because of this 4V. The problem is the existing models, or in other words, early models, statistical models, data mining models, analytical models were not enough to scale up to be able to resolve and find solutions this incoming problems. Why it was a problem? Because the volume of data increased dramatically, and variety of data, which means different forms of data. We don't use the relational databases or Excel spreadsheets anymore, because data can come in any form. It can be sensor data, it can be text, someone tweeting, someone uploading picture, YouTube videos, Internet of Things, smart homes, automated vehicles. We have to deal with any forms of data to be able to address the changes with our existing solutions. So we had to improve the analytical approaches. And the third one is the velocity, right? Like real-time processing became so available. It's not that important batch processing or how accurate your models are. You also have to do predictions very fast, and you have to ingest the data very fast, which require you to handle the whole analytics pipeline end to end. It's not model development. It's also including deployment. It also includes data organization and maintenance. So you have to deal with all these phases in order to provide a good analytical solution. And veracity is the last V. Actually, there's one more. The veracity is how accurate. Like we are dealing with a lot of data, but how we are going to rely on the data to be able to train our models, how we are going to make sure that we are using the most accurate incoming data to be able to solve our business problems. It's the another dimension of big data. Have you ever seen this before? How many of you heard big data and explain and learn in different dimensions like this? I want to ask for the incoming students.
Yeah, I've heard of it.
Great. So
Yeah.
we are familiar.
Yep.
Okay, perfect. Then let me go a little bit deeper on this. When we talk about, if we take the one dimension, the volume, you would see these things like Facebook store 400 petabyte data with an incoming data rate of 600 terabyte, which these are not going to mean anything to you. However, I will show you what the physical occupation of this size of data. YouTube 1000 petabyte, Google 4 million search per minute stores 10 ecobyte data, AT&T, US credit cards. And I like this slide and I use it a lot in almost everywhere because we have to deal with what, if you think about that 1 gigabyte is occupying 10 inches in diameter in real world, we're talking about petabyte, terabyte, gigabyte is the least important, and 1 terabyte, 800 feet diameter, and 1 petabyte is actually corresponds to 150 miles diameter, which is almost equal to the ground distance from Boston to New York City. So to store this much data, solving the analytical problems, dealing with all these V's that we just discussed may not be sufficient in the future. So we always have to be very good at in the big picture how we are going to actually tackle the incoming problems, especially with the physical occupation. Another problem that I want to address, and I want to emphasize this as much as I can, failure rates for analytics projects 85% because of a lot of reasons. The reasons are, it doesn't mean that the models, analytical models are not good, but it's not deployed well, or it didn't respond those 4 V's. It was not efficient. So in the end, the companies and existing industries are not making the full value from data science projects. And in this program, we have very special focus, and we have an updated curriculum to be able to bring a project to a value in all for all the skills required that you're going to be equipped with, hopefully, to be able to shine in this journey after your graduation, because it requires a lot of different types of knowledge. We have to learn data science, we have to learn a little bit of algorithms, we have to bring the business domain expertise with the help of your instructors and heavy relationship to the industries. We are going to go deeper in the math in some of the cases and some not. Statistical analysis, software part, data engineering, you're going to equip yourself. We will also talk about the ethics while we are doing all of these, how we are going to make sure the value is credible and reliable. And also social and organizational science, the information and the disciplines are also intervened with our program for a good analytics project and process. Most recently, what I want to talk about is we are organizing, for example, a COVID hackathon soon by using a lot of different data sources. The alumni and the existing students are going to be joining. We wanted to make an impact, and we wanted to show what we have learned in this program to be able to tackle with this very popular trending problem. What we are trying to do, for example, in the first case, can we predict the infectious rate or the risky areas in the Cook County in Chicago to be able to help the city of Chicago? Hopefully, there might be something like that. As a result, we can obtain, or disease spread in certain areas. One interesting hackathon question that we are also focusing on: economical reactions after the reopenings. As you know, there are a lot of states are reopening and we don't know which one is working, which is not working, and how the effects are going to be after all those decisions. We can incorporate analytical skills, little bit about econometrics together to be able to understand the effects of this pandemic. And for example, in the last question that we are trying to solve with the hackathon is we realize that clinical trial process for new drug or new vaccine is too long, and we interacted with a lot of domain experts that the recruitment for those tests and trials are taking so much time, and we wanted to bring the inclusion exclusion criteria, how we can use the analytical skills that we learn in this program to be able to identify most eligible patients in the most fastest and the quickest way to be able to reduce the patient recruitment time window, which I think is going to be critical for the upcoming healthcare problems and pandemics as well. That's why we are very excited to be able to open up this kind of research and show and demonstrate our work and capabilities to be able to answer and tackle these problems. Any questions so far? I don't want to go too deep, but I think I'm having like almost 20 minutes that we spend at Charles can ask us back, but before we leave the breakout room, I would like to answer your questions. We are doing a lot of other things. We are doing very good capstone projects. We have very good relationships with different industries and different companies. We are basically utilizing every option in the Chicago area. And it doesn't have to be in the Chicago, but our program's reputation is growing and growing because the companies are finding the deliverables and the outcomes of the projects are very useful and valuable. They also want to keep working with our students, so which is good signs for us as well. So we are all happy with the performance grow in the last couple of years. Okay. I think I can stop sharing in here and we can talk and we can answer. Alexei is here, existing students are in here, I'm here, and we would like to give you a warm welcome by answering your questions in other things if we didn't cover as well.
Hey, this is Mike. We can call me Xiaoyang. Nice to meet you. Sorry, how can I pronounce your name?
Utku.
Utku.
Yeah.
Okay, Professor Utku. So like I wanted to ask you about like the capstone project, like how people usually form like the team and how you say we're gonna work with the actual company with like maybe with their data. Like, do they just give us like the CVS file, or we have to grab it from their like some sort of like a GitHub or their database or something?
So it depends. It depends which company that you're working on. We are going to give you a much broader information about the capstone process. Actually, we are going to talk about this in your orientation as well before the program starts. But usually what we are doing is we are picking the best applicable options we have. We are posting them online, and based on the size of the company, it can be a startup, it can be a fortune company. The data provision becomes either through their virtual environments, or we are having them in our RCC, Research Computing Center, University of Chicago. We have good computation capacity. There are different ways that, based on the sensitivity and the size of data, there are different ways that our students are getting access to the company data.
Gotcha. And also, if is there any like research opportunity? I know this is like a for professional program, but since I never done like any research before in my like undergrad, ever, I'm kind of curious like how like what's like to do a research during a school or academic year. Is there any this kind of opportunity with around this program or within the University of Chicago that can relate back to my major, which is analytics? Yeah.
Interesting question. Like, research is always a part of this. And for example, most of our faculty is coming from PhD and academic backgrounds. And in the capstone writing process, you're basically creating a technical research paper to submit and grow on. And in addition to that, you can think that form as a MS dissertation. Some of our students were interested in continuing the PhD program because the whole research experience during the capstone and doing collaboration on other projects with other faculty are actually preparing them real research rigor if they're interested in. It's not that much, but I have seen some examples who want to follow that track. But we have enough preparation for you to teach you how to design the research, especially in the capstone process, that you're going to be familiar, and hopefully you're not going to have any difficulty to apply the skills that you have learned.
Gotcha. Thank you so much.
Oleksiy, our student, do you want to say something? He was really excited before coming. Now I want to hear his feelings, actually. How do you feel? Where are you right now, Oleksiy?
I'm at home. So yeah, congrats again. A couple of words. I think the program is fantastic, and I'm in the first quarter. I took a class with Professor Pamuksuz, right? And I'm taking a class with him again. I would like to highlight that people are super helpful here, especially in these times. I was very concerned. I discussed with Greg Green this program, how it will go. People are willing to help, professors, everybody. So everybody super supportive. If you're concerned, nobody knows what will be in the fall when you join. But I think the quality of education, in my opinion, didn't suffer a lot. The education is fantastic. It's a little bit more difficult in terms of collaboration, so you need to adapt here. But this is, I took, my background is not very data science, but I took classes in programming, statistics, mathematics before. And like, I see this program is fantastic. I'm talking to
That's a great point. Sorry, I want to add something on that. The biggest power of us, we are like a family, and the biggest power of the quality of the students, that we are doing peer learning as well. That's why when everything gets online, I was scared that how our students are going to be actually leverage from each other's skills, because as a University of Chicago students, we are also using that power and network. And we do a lot of precautions to be able to provide that networking opportunity to you as much as you can. We are working really hard on that. Thanks, Oleksiy, for bringing up. Actually, I forgot to mention about